Today we're going to talk about inductive and deductive reasoning. Starting off with inductive reasoning. And inductive reasoning is when we find a pattern. We see 1, 2, 3, 4, 5. What's the next two numbers? 6, 7. Okay, so we're going to look for a pattern. And then we're going to write a conjecture for the general case. So 1, 2, 3, 4, 5, and then we're going to continue counting sequentially. Something of that nature. What is a conjecture? Great question. Well, conjecture is an unproven statement that's just based on our observations. So we're going to see what's going to go on, and we're going to conclude that every day the sun is going to rise in the east, because that's what it did every other day. All right, so let's look at our first example. We're going to look at the first three figures and then figure out how we want to sketch the fourth figure so it fits the pattern. So figure 1, we cut it in half and we shade in the top half. Figure 2, we cut it in half twice, creating equal pie parts, and then shade in the top left quadrant. Okay, figure 3, we're gonna cut it in half 3 times, creating equal pie parts, and shade in the piece on the left, just above, just into the northern hemisphere. So figure 4 is going to be a circle, and we are going to cut it in half north-south, and then we're going to cut it in half 3 more times, creating equal pie pieces, or hopefully equal pie pieces, and then we're going to shade in the piece on the left just above, just into the northern hemisphere. So that fits our pattern. That's what we've noticed. Let's look at another one. So here we're starting with a box. Then we're going to add a box on the top and on the left. Then we're going to add another box on the top and left. Figure 4, another. And so figure 5, we're going to do the same thing. And I'm going to cheat and copy and paste. And we're going to add, we added to our pattern. That's what inductive reasoning is, noticing a pattern and figuring out how to continue it on. All right, so in the first example, when we had our circles and our pieces of pie, now we're going to add the fifth figure. So we're going to start with our circle, hopefully. Okay. But now we're going to cut it in half 5 times, creating equal pieces. 2, 3. All right, now we're going to color in the piece on the left, just into the northern hemisphere. And it's a sketch, so we don't have to measure. It doesn't have to be exact. All right, let's continue to work this, our inductive reasoning. So we're going to describe the pattern, and then we're going to write or draw the next 2 numbers or letters or figures. So S, R, Q, P. Well, if we went PQRS, that's alphabetic order. So we're actually going in reverse. Alphabetic order. So our next two are going to be O and N. All right, let's look at our numbers. So we're going to go from 1 to 2, 2 to 6, 6 to 24. All right, so this is our first figure, our second, our third, and our fourth. Okay, and let's see. 1 to 2, we add 1. 2 to 6, we add 4. That doesn't make any sense unless we're doubling it. So then we would add 8 to 6, but that's not 24. So if we go 1 times 2, we get 2. 2 times 3, we get 6. 6 times 4, we get 24. Okay, so we're going to multiply the previous number by the next number. So here we're going to multiply by 5. 24 times 5 is 120. And we're going to multiply that by 6. Why does this keep doing that? By 6 to get 720. Okay, not too shabby. Now I got to draw some stars, which is going to be probably a little bit of an adventure. But we can see that our stars don't change. But what changes is what is shaded in. So we're going to draw the next two stars. And in the first star, we've got the center colored in yellow and 4 points. In the second one, we've got the center yellow and 3 points. Third one, center yellow, 2 points. And it's moving counterclockwise. So we expect this point to be colored and the center to be colored yellow, like so. And in the fifth one, we know the center will still be colored, but no points should be colored. So that's what we mean by developing and continuing a pattern. Patterns are very important to us when we're talking about inductive reasoning. So let's use these numbers and try to figure out what our pattern is. All right, so we got a group of 3 numbers. And if we add them up, 3 plus 4 plus 5 equals 12. All right. Well, 12 we know is 4 times 3. So, okay. 7 plus 8 plus 9 is 24. 8 goes into 24 3 times. Okay, 7 doesn't go, 9 doesn't. 10, 11, 12, 33, so 11 times 3. And 16, 17, 18, add to 51. And 51 is 17 times 3. So what's our conjecture? The sum of any 3 consecutive integers because we didn't deal in any decimals. So we only want to deal with integers for this, is 3 times the middle number. Okay, so now let's test it. Let's pick some other numbers, some consecutive numbers, and let's pick some bigger numbers and some weird numbers to see if it works. So let's start at -1 plus 0 plus 1 equals 0. And 0 times 3 is indeed 0. So it works. But what if we pick 101 plus 102 plus 103, and that's going to equal 106. And if we divide 106 by 3, we get 102. So our conjecture holds up, which is what we were hoping for. And when we create a conjecture, what we want to look for is a counterexample. And a counterexample is a specific case where the conjecture is false. And the reason we look for a counterexample, a conjecture has to be true for all cases. And if we find just one counterexample, that conjecture is false. So let's try to find some counterexamples. The sum of two numbers is always more than the greater number. Okay, so let's find a counterexample for that. So let's start with negative numbers. So we're going to add up two negative numbers. -2 and -3 equals -5. And we know that -2 is closer to 0, so it is bigger than -3. All right. So according to our conjecture, -2 should be smaller than -5, but it's closer to 0, so we know it's bigger. So that is not true. We found a counterexample. Our conjecture is wrong. So that's how that works. Okay. Move right along. Make and test a conjecture about the sum of any 5 consecutive integers. All right, so let's add some up. 2 plus 3 plus 4 plus 5 plus 6. 4 and 6 is 10. 2 and 3 is 5 plus 5, so that's 20. Well, 20 is 4 times 5. Okay, so let's do another one. And we'll start at a negative. Plus 1 plus 2. And -2 plus 2 is 0. -1 plus 1 is 0. Plus 0 is 0. And 0 equals 0 times 5. So here we're going to have, very similar to our 3, is the sum of any 5 consecutive integers is 5 times the middle number. Any 5 consecutive integers is 5 times the middle number. All right, let's get another example. We're cruising. Make and test a conjecture about the sign of the product of any 3 negative integers. So let's just pick -5 times -2 times -1. That's going to equal -10. So I got three minuses I'm multiplying together. So our conjecture is the product of any three negative integers is negative. So this is what we're attempting to do. Now let's find a counterexample and see if we can prove that our conjecture is false. The value of, that should be x squared, is always greater than the value of x. So if I have x equals 2, x squared to be 4, which is bigger than 2. But what if I set my x equal to 0? Well, 0 times 0 is 0. So this is our counterexample, and our conjecture is false. Find a counterexample to show the conjecture is false. All right, the sum, here's our conjecture, of two numbers is always greater than their difference. The sum of two numbers is always greater than their difference. All right, so if I take 5 plus 3 equals 8, and then 5 minus 3 equals 2, that's what my conjecture is telling me. So what if we did negative numbers? -5 plus a -3 equals -8, and -5 minus a -3 is going to equal -2, and -8 is less than -2, so our conjecture is false. And in the next video, we're going to pick up deductive reasoning.